Hi guys, in this video we'll be discussing the problem D from code forces round 842, and the problem states that you are given a permutation P of length n. In one operation you can choose any two indices I and j and swap Pi and Pj. We have to find the minimum number of operations that are needed for the final array to have exactly one inversion in the permutation. Then they have given us the definition of permutation and inversion. We would be going over the concepts in the solution, so won't be reading that aloud. Then they have given us the size of the inputs. So t, that is the number of test cases, will be less than or equal to 10 to the power 4. N, that is the number of elements in the permutation, would be less than or equal to 2 into 10 to the power 5. After that, they have explained how they have given the input. So over here we have 4 test cases. This is the first, second, third and fourth test case. We just have to return the number of operations that are required. So with that, let's get started. So let's firstly just quickly go over what a permutation is. So permutation basically is any way of representing numbers from 1 to n. So the numbers from 1 to n can be arranged in any fashion, and that would be a valid permutation. But what is an inversion? So inversion is defined as two elements are called inverted if I is less than j. So I is less than j and the element at ai is greater than aj. For example, if I have a permutation, let's say 1, 4, 2, 3. So what I'll do is I'll stand at a particular element, I'll look to its right, I'll check if it has an element that is smaller than that. So for 1 I have no inversion because no element is smaller than 1 on its right. What about 4? 4 has two elements that are smaller than it to its right, so I'll say for 4 it's 2. What about 2? 2 has no elements that's smaller than it to its right, so it's 0 for this as well. Similarly for 3. So the entire array only has a inversion of 2. So that's what inversion basically means. Cool. With that, let's move ahead. So what they want us to do is to calculate that the final array, after performing all that sort of operation that we can perform, the final array should have exactly one inversion. Now, is it possible to make one inversion, and if, then how can we make it? So let's say I'm given a sorted array. So a sorted array, for example, let's say a permutation of 5 elements. So how many inversions does it have? A sorted array definitely has only zero inversions, so there's no inversion for any of the elements. What if I swap any two elements? Now let's say I swap 4 and 2, then what would happen? So it would become 1, 4, 3, 2, 5. Now 4 has two inversions, 2 has 9 inversions, 3 also has one of the inversions, so the total number of inversions is 3. Now we realize that if we swap two elements that are not consecutive, the number of inversions could be greater than 1. For this example, it was definitely greater than 1, it was equal to 3. But what if we like swap two consecutive elements? So let's say we swap 2 and 3, so it would be 1, 3, 2, 4, 5. Now only 3 would be the element that would have a single inversion in the entire array. This is because when we swap any two consecutive elements, then the element that is at location I plus 1 comes before the element that is at location I. So I plus 1 gets an inversion, and this is the only change we have made in the entire array. So only one inversion happens. So from that we can say that the final array should be actually a sorted array. The final array that we are going to make is a sorted array that exactly has one inversion in it. So it would be exactly sorted, but at a location I and I plus 1 would be swapped. But we have to tell the number of operations required, right? Number of swaps required. From this we can tell all the possibilities of the correct answer, but actually we require the number of swaps and not the final answer of the array itself. So how would we calculate the number of swaps? Now let's consider it wasn't asked us to like they hadn't asked us to calculate uh, inversion 1. Let's say they just asked us to calculate the number of swaps required to sort the array. So what we could have done is that we could have taken the array and checked what all any elements are not at the correct position. So let's say this was 2, this was 3, this was 1, this was 4, this is 5. So over here in the correct array or in the sorted array, the elements would have been 1, 2, 3, 4, 5. So we could have said that okay, 1 is not at the correct position, so is not 2, so is not 3, but 4 and 5 are at correct position, so 3 elements are not in the correct position. But we have to swap it. So how do we go about that? So what I can say is I can start detecting cycles. I can say that 2 should have been over here, right? But here I'm finding 3, and 3 should have been over here, but here I'm finding 1, but 1 should have been over here. Here I'm finding 2. So it becomes a cycle wherein we have 2, 3 and 1, and then 1 goes back to 2. So for a cycle which has 3 elements in it, I need n minus 1 swaps. Or for a cycle which has 3 elements in it, I need 2 swaps. So in 2 swaps, what I can do is that I can swap 1 with 2. So I'll be having 1, 3 and 2 in one swap. After that I can swap these 2 elements, so I'll be getting 1, 2, 3. So now we know that in n minus 1 swaps, we can make any array which has a single cycle of n elements sorted. Also, if it has many cycles with let's say ai is the length, number of elements in the first cycle, a0 is the number of elements in the first cycle, a1 is the number of elements in the second cycle, a2 and so on. So the number of swaps required would be a0 minus 1 plus a1 minus 1 plus a2 minus 1 up to so on. So this is pretty trivial, but over here can we use this particular logic? So for using this exact logic about cycles and then going about checking all the sorted arrays, so basically as we told that in the final answer the array should be sorted except for 2 consecutive elements that should have been swapped. So there are n minus 1 possibilities for these kind of arrays. Now checking for cycles and all is a order of n operation. If we check for all the possibilities, it would take me order of n squared time, which would give me a TLE. Is there a way of doing it in order of n itself? Turns out yes, we can do it in order of n. So we'll be following the basic algorithm that firstly we'll try to find the cycles that are possible, and for each cycle, so let's say this was one cycle that was getting formed. Let's give it any number. Let's say it's 1, let's say it's 2, 3, 1. There was another cycle, let's say 5, 6, 4. So we'll be assigning the cycle group IDs. So let's say this had a group ID of 1, this had a group ID of 2, so on and so forth. Then I'll be getting the number of swaps required. So that's pretty straightforward. So I'll definitely be getting the number of swaps required to convert it into a sorted array. So that we already discussed. After that, what I can do is that for 2 consecutive elements, I can check that if these 2 consecutive elements actually belong to a single cycle, then I don't need to do anything. On top of it, I can do that whatever my answer was, I can subtract 1 from that, because these 2 elements need not be at their correct position, they can be at this position itself. So I'll be subtracting 1 from my answer and I'll be returning it. But what if I'm not able to like there's no such 2 elements that are from a single group? In that case, I'll just return. Okay, so over here answer is basically the number of swaps I was doing. So let's call it, pardon for my handwriting. Okay, so let's call it swaps. So let's just print cout minus 1 in case I was able to find 2 consecutive elements within the same group. If I'm unable to do that, then I'll have to cout swap plus 1. Now where this plus 1 comes from, because once you have created the sorted array by swap operations, you'll have to perform one more swap in order to interchange any 2 consecutive elements. So that's where this one more comes from. I hope the logic behind this is clear. Let me know in the comment section if you still have any doubts in it. Now let's talk about the algorithm for this. The algorithm is pretty simple. So initially I've taken n, that is the number of elements, then I've taken the entire array. After that I have decreased all of those elements by 1 itself. The reason I have done that is to make it 0 indexed. Post that, I'm calculating the number of like I've written a variable cycles, so it will calculate the number of cycles that are present. Also I have res and I have group id. So group id is basically what we told that for each of the groups we'll assign them a id so that later we can use it. Then I have a vector group. So vector group is of n elements, and for each of the n elements it would represent the group id it has. So initially I'm putting a dummy value over here. My dummy value is 0. Then I'll start traversing. I'll check if the group id is set to 0. That means I have not checked for this particular element. Then I'll go inside the loop, and every time till the loop runs, that means the number of elements are increasing in this particular group. I'll keep incrementing my cycles. So I could have given it a better name, but for now it's cycles over here, so let it be. I'll keep incrementing my cycle. I'll keep changing the variable also, so that I'm able to detect the number of elements in that particular cycle. After that, and for all the elements in that particular cycle, I'll be assigning them the same group id. Once I'm out of this loop, so all the elements in that group have been completed, so then I'll be increasing the group id by 1, so that when I come in this loop again, so it's not the same group id, and I'm able to distinguish between two different groups, and increase my res by cycles minus 1. So as I told that for n elements you need in a cycle you need n minus 1 swaps, so that's why I'm subtracting 1 over here. After that, over here the rest would actually contain number of swaps required for sorting the array. So we need to perform one more operation on this, that is, what if can I swap two consecutive elements. So over here I'm checking the exact same thing. So if two consecutive elements, that is I and I plus 1, have the same group id, then I can readily return result minus 1, as we had already discussed in the video. If that doesn't happen, then I'll have to return res plus 1. So I'll try running this particular solution. Okay, so yeah, you can see this is the test case, the dummy test case they had provided. For that, it's working fine. Let me try to run it over here as well. Okay, so I guess there's some issue with it. I don't know why. Probably just that the contest just ended and they don't allow it right now. So anyway, this solution should definitely work. You can try this out on yourself. I'll try to put like a comment below this post which actually has the link to this particular code. I hope you enjoyed the solution and you got the gist of it. Thanks a lot for watching the video. Bye bye.